today we will discuss about the type of source. Actually, we have two types. It's going to be dependent source as well as can be independent source. For the dependent source, it depends on a parameter. Can depend on currents or voltage but in the independent source does not depend. So in the independent source, this one is a independent source. The value, just to let, for example, 9 volt. The value is constant. It does not depend on parameter. It can also be a current source. If this current source is going to be like this one, mean that this one is the positive terminal, this one is the negative terminal. But when we do the arrow, we don't need to put the terminal, because we just from the arrow, such as this one, we directly know that here is the positive, here is the negative. So now we have the dependent source. The dependent source, it can also be a voltage source, which it will be in this notation. Now plus and negative terminal. We have the positive terminal, we have the negative terminal. In this notation or in this form, it will be dependent source. So it will depend either on voltage, such as I can be like this one, 2Vx. For example, this value, the voltage of this source is depend on a parameter. It depends on this voltage Vx. Mean that if I have the value of Vx, let's say for example Vx equal 4. So in the voltage of this source is going to be 2 multiplied by 4 equal 8 volt. The 8 volt is the voltage of this source. It can also be like voltage source. It can also be a current source. If it is current source, the notation will be so if it is a current source dependent voltage source, but let's now is depend on current. It can also depend on current. It will let, for example, 2Ix. Mean that now this dependent voltage source is dependent on current Ex. If I have the value of Ex, let's say for example Ex equal 3 ampere, so the voltage of this source is going to be 2 multiplied by 3 equal 6 volt. That's the voltage of this source. Now we have the dependent current. Dependent current source, which we say it can be like this one. We have this arrow. The arrow can be in this direction, the arrow can be in that direction. In this case, we already talked that if the arrow is in this direction, means that here it is the positive terminal, here's the negative terminal. So it can also be dependent current source, which depend on voltage, to Vx. Means that this current source depend on a parameter Vx. If I have the value of Vx, I can directly determine the current source of this one. It can also be a current which depend on parameter Ex. Ex means that current dependent current source. Means that if I have the value of Ex, I can directly determine the current of this source. That's the different type of source. The source can be dependent source or independent source. If it is dependent source, if it says it can be voltage source or current source. We saw also the notation of the source, of the dependent source, and how to determine the voltage or the current of the source by knowing the parameter, the dependent parameter. Next, we are going to see the power. The power we already know. We discussed in the previous video that the power is the rate of energy that's consumed in 1 second. So now, in electric circuit, there is two types of component. There is some component that supplying power, there is other component that absorbing power. Some component that supplying the power, the other component that absorbing the power. Generally, the source are supplying power. That's the most, but it is not compulsory. Sometimes can consume. So now let's see how can we determine that this component, such components, are consuming power or absorbing power or supplying power. Let's say we'll use the law of the direction of the currents. If currents, let's say for example we have this source. If currents, the current is leaving in the positive terminal, we see the current is leaving this positive terminal. Mean, or for example we have this component, we have this one, plus minus, that's the positive terminal, that's the negative terminal. The current is leaving in the positive terminal, mean that the component is supply power, mean that this component are supplying power in the electric circuit. And when the component is supplying power, mean that power is negative. The power is going to be negative. Why? Because is losing the power. So the power will be negative. We'll consider as negative. When? At what time? When the current is leaving from the positive terminal. Now, we can also say, in the same analogy, when the current is entering in the negative terminal. When current, this one is leaving from the positive terminal, is going to enter in the negative terminal. Same as this one. So we'll see. If the current is leaving the positive terminal, means that it supply power. If the current is entering the negative terminal, means that is supplying power, the component. But now, if the current is entering in the positive terminal, Now we'll see if the current is entered in the positive terminal. If the current is entered in the positive terminal, mean that the component is going to absorb power. Mean that the power is going to be positive. In the same analogy, the current is entering the positive terminal. We can also say if the current is entering the positive terminal, we can also say if the current is leaving in the negative terminal. You choose one. You can choose one. You can keep like if the current is entering the positive terminal, mean that is absorbing power. If the current is entering the positive terminal, is absorbing power. And if the current is leaving in the negative terminal, mean that it is supplying power. So now we have the what we call the Thellegens theorem. Why Thellegens theorem say that? In electric circuit, the power supply, mean that the summation of the power supply plus summation of power plus summation of power absorbed is going to be equal 0. That's the Thellegens theorem. The Thellegens theorem say that the summation of the power supply plus summation of the power absorbed, it is equal 0. Let's forget about this one. That's the Thellegens theorem. You have to keep in mind that in electric circuit, the summation of the power supply is equal to the summation of the power absorbed. Let's see, for example, if I have this electric circuit, I have this electric circuit. So I have P1, I have P2, I have P3, I have P4. So let's say, for example, so this current is, I have this current, I have this current here, I see that I have this current here, I have this current here. I have this current here. This current, if we see this source, the current is leaving in the positive terminal. Mean that P1, mean that this source is supply. We already discussed that if the current is leaving the positive terminal, mean that supply. So P1 is negative. Now the current is coming here, is entering in the positive terminal. Mean that P2 is absorbing. means that P2 is going to be positive. Now we see P3, this current is entering in the positive terminal here, so P3 is also absorbing. P3 is positive. So now P4, if I see this current is going to enter in the positive terminal, so P4 is absorbing. So P4 is positive. So actually not like P4 is absorbing the source, but in manner to just to write, I just write P4 is absorbing, but it means that the component itself. So now I have the supply, I have the absorb. Using the Thellegens theorem, we see that the power supply, summation of the power supply, how many power I have in the supply? I have only P1. P1 is the power that is going to be supplied, plus that one is only this one for the supply power, plus the power absorbed. Power absorbed, I have P2 plus P3 plus P3 plus P4 is going to be equal 0. That's the Thellegens theorem. Summation of the power supply plus summation of the power absorbed is going to be equal 0. In the next video, we will see some example of the Thellegens theorem and how to determine the power. Thank you for watching.